Mars, Earth's cosmic neighbor. More than 40 spacecraft have been launched to the Red Planet, seeking to unlock its secrets. Now, NASA's new Perseverance rover is on a quest to crack the planet's biggest mystery. Was there ever life on Mars?
Ever since the very first mission to land on Mars, we've been looking for signs of life. We've seen tantalizing clues. This could be the mission that finally answers the question.
How will Perseverance succeed where others have failed? Could this mission discover that living things exist today on the Red Planet?
If the Perseverance rover finds life on Mars, that will change science and philosophy forever.
And how will Perseverance lay the groundwork for humanity's next giant leap in space exploration?
Someday, there will be humans who no longer identify themselves as Earthlings, but they will call themselves Martians.
To find out, we will venture to the Red Planet. Voyage beneath its mysterious dusty surface and explore its alien underworld to reveal the secrets of this pioneering mission to Mars. Mars. From orbit, the planet looks barren. Temperatures here plummet to minus 220 degrees Fahrenheit. Its thin atmosphere is 95% carbon dioxide. Cosmic radiation, over 30,000 times stronger than on Earth, blasts the surface. Probes and rovers sent to Mars confirm that it appears to be a lifeless desert world.
When you look at the images the rovers and landers have sent back from Mars, it looks dry, dead. But that's Mars now. What was it like a long time ago? Well, the evidence for that shows a very different world.
Many space scientists believe that life could have once thrived on the Red Planet.
Mars just squeaks in on the edge of what we like to call the habitable zone. Now that means the region in a solar system where liquid water could form and could exist for long periods of time. We know that water is the source of life on Earth, and it might have been the case on Mars.
NASA has sent 4 rover missions to explore Mars since 1996. NASA's 5th rover mission, called Mars 2020, is the first tasked to seek out evidence of life on Mars. This is Perseverance. It's a 6-wheeled robotic vehicle about the size of an SUV.
Perseverance is the most ambitious rover we've ever flown into space and that has ever gone to Mars.
Perseverance carries a suite of super-sensitive instruments, ground-penetrating radar, onboard chemical analysis, and X-ray detectors to sniff out the signs of ancient life.
Every single inch of the rover has been carefully thought through and designed. All of this effort is in support of a chance to really ask the question, has life ever existed beyond Earth?
July 30th, 2020. An Atlas V rocket blasts off from NASA's Kennedy Space Center. 1 hour after launch, the capsule carrying Perseverance rover separates and heads out into space. Destination, Mars. Launching a rover into space and traveling more than 130 million miles to Mars is the easy part of this mission. The bigger challenge is how to land a 1-ton rover on the Martian surface. NASA engineers borrowed the multi-stage system used to land the Curiosity rover in 2012. It's a proven platform for getting robotic vehicles from space onto the surface of Mars.
The heat shield comes into the top of the atmosphere. That starts to slow us down a bit, but not nearly enough. We have to release the parachute, but the Mars atmosphere is thin, so the parachute is not good enough on its own. It doesn't slow us down enough to get to the surface safely.
Now falling at 180 miles per hour, Perseverance is ready to make a controlled touchdown.
We come down on retro rockets, hover, lower the rover down on the sky crane, and then once it touches the surface and releases that tension on the bridle, pyros fire, cutting those cables. The descent stage flies away to a safe distance and crashes, and the rover is just there, ready to go. It's tremendously exciting and nerve-wracking.
With Perseverance now landed safely on the Martian surface, the rover's mission begins. Mars is just over half the size of Earth. Where within this huge area should Perseverance look for life?
If you're looking for life on Mars, finding evidence of this life or past life isn't going to be equal in all places. For example, if you land in the Sahara on Earth versus the Amazon, you're going to have a very different outcome. The planet is big, the rover is small, so it's key that you put the rover in the right spot.
The key to finding traces of ancient life on Mars is finding signs of water. Liquid water is a super solvent. It allows lifeless chemicals to mix and transform into biological systems.
If there's one thing that Earth teaches us about life, it's follow the water. Where you find water, we found life on Earth.
There are no obvious signs of liquid water on Mars today. How can scientists locate where liquid water on Mars once used to be? In 2004, the twin Mars rovers Opportunity and Spirit beam images back to Earth that could unlock the answer. The cameras on board both rovers photographed these strange Martian objects. Each one is roughly 1/5 of an inch across. NASA scientists call these objects blueberries because of their shape and color in these photographs. Analysis reveals that these blueberries are made from iron oxide. And one theory claims there's only one way that these rusty balls can form. Blueberries start life as tiny specks of crystals that exist inside waterlogged rocks. Iron oxides from the rocks wrap around the crystal spheres like rust, turning them into small iron balls, blueberries. Thousands of these can form near each other. But to grow, they need huge amounts of water to flush more minerals onto them. Over millennia, strong winds erode the soft stone around the hard blueberries, releasing them onto the surface. The blueberries are evidence that Mars once had rivers and lakes. It's even possible that the red planet had oceans of liquid water 4 billion years ago.
With all this evidence and all this data over all these years, the story is clear. Mars had rivers and river channels. This means that the probability that Mars harbored life is very high.
NASA research finds evidence that water covered 1/5 of Mars for over 1 billion years. That's an area almost 40 times the size of Texas. Too large for one small rover to explore in detail. Where on Mars should Perseverance focus its search for ancient life? And what will it look like? NASA's Perseverance rover is on a mission to find evidence of ancient life on Mars.
The Perseverance rover and all of its subsystems, everything about it is really this concentrated effort in support of exploration and discovery, scientific discovery, a chance to really ask the question, has life ever existed beyond Earth?
Scientists believe these traces could exist where water covered the red planet 4 billion years ago. This area could make up as much as 20% of the surface of Mars. So where in this vast area should the rover target?
When you're trying to find the perfect spot on Mars to look for the evidence of life, one of the things you need is standing water for a long period of time, something that wasn't just wet for a few days and then dried up.
A clue to where to search for ancient life lies in photographs taken from 180 miles above Mars. Mars Reconnaissance Orbiter, or MRO, is a satellite that orbits the red planet. Its camera captures images of the Martian surface in stunning detail.
The Mars Reconnaissance Orbiter is essentially a spy satellite in orbit, but instead of spying on the planet, it's mapping it so that we can better understand it.
NASA scientists search the MRO's photographs for the traces that ancient rivers and lakes leave behind. They find an intriguing feature in Jezero Crater, a deep depression close to the Martian equator. It's likely that Mars had lakes and rivers 4 billion years ago. An asteroid, or comet strike, explodes a mega crater 28 miles across. Over time, 2 rivers break through its rim. They create a deep body of water the size of Lake Tahoe. On its shore, the rivers form fan-shaped deltas that are still visible today. Long after the water the lake held for millennia dried up.
So in Jezero Crater, we find not one, but 2 beautiful river deltas. Now, deltas are formed over a long period of time as a river enters a larger area, like a lake, slows down and drops its sediment. We know this had to be wet for perhaps millions of years, a perfect place to look for life.
NASA scientists use a powerful camera on the MRO to analyze the rocks in Jezero Crater in more detail. Images from the camera reveal that the rim of the crater is made from different types of carbonate rock. Carbonates on Earth form when the shells and bones of microscopic animals build up in layers on the floors of lakes and oceans. These photographs point a giant marker at where the Perseverance rover should concentrate its search for Martian life.
In addition to being filled with water at one time, Jezero Crater is also ideal because it has this carbonate rock lining the inside rim of the crater. And these carbonates on Earth create fossils. If Perseverance is able to study these carbonates, then that gives us the opportunity to maybe find fossilized life.
We're extremely excited about Jezero Crater. We have an incredible landing site that's the result of many years of scientific debate and really gives us everything we're looking for in a landing site for Mars. So we are all systems go for Jezero Crater.
The Perseverance rover has its target. But what should Perseverance search for? What could the remains of Martian life look like?
The only place in the universe that we know for sure life exists is Earth. So we can only use Earth as our best possible guide in the search for life. The best way to search for past evidence of life on Mars is to assume that it evolved in a way similar to that on the Earth.
Around 3.8 billion years ago, oceans of liquid water start forming on Earth, triggering the beginning of life on our planet. In the warm seas, simple chemicals combine into complex biomolecules and the first single-celled organisms. Some of these organisms develop photosynthesis, and for over 2 billion years, they fill Earth's atmosphere with oxygen. Only in the last 600 million years does life evolve into a vast array of complex animals and plants.
And when we look at Mars, clearly there aren't giraffes walking around, right? There are no alligators. So I doubt that there are large life forms on Mars. The highest probability is that it's microbial life.
Bacteria and other microbes are single-celled organisms. Most of them measure only a tiny fraction of an inch across. What will the remains of this microbial life look like today? And how can Perseverance find them on Mars? NASA's Perseverance rover is hunting for evidence of ancient microbial life on Mars. What do these remains of living things look like after 4 billion years on the Martian surface? Ancient shorelines in Jezero Crater could hold the answer. These shallow waters may have been an ideal place for life to flourish. On Earth, microbes can group together on lake beds to form patches of sticky microbial mats. In time, these turn to stone, and new layers of microbes grow over the top. After many thousands of years, they grow into layered pillars called microbialites. Finding remains of such structures on Mars could be evidence that life once thrived here.
Billions of years ago, Mars was warmer and wetter, much like Earth is now. Well, life on Earth arose billions of years ago, and we find evidence of that. So by investigating that, we're learning about ways we can look for that same sort of life that may have existed once on Mars.
A clue can be found in the Pilbara region of Western Australia. This is one of the most ancient landscapes on Earth. Here, NASA scientists investigate fossilized microbialites that are 3.4 billion years old.
It's in these rocks that we find these first clear traces of microbial life fossilized in the geologic record. And the traces are clear. There are some shapes that are complex enough that we find it impossible to imagine a mechanism other than biology that could build them. It's possible that we could observe something similar on Mars.
The high-resolution cameras on board Perseverance could photograph the fossilized remains of microbialites on Mars.
If the mass cam turns around and takes a picture and sends it down to Earth, you know, my heart would leap for joy. The implications are so large that we really would need to confirm it with follow-up observations.
If Perseverance were to actually take an image of a fossil on Mars, and if we could verify that that fossil is actually evidence of past life on the planet, that would be one of the greatest discoveries in human history.
Finding fossils of tiny microbes on a world hundreds of millions of miles away is a long shot. The conditions on the surface of Mars make it unlikely that intact microbialites exist. Millennia of exposure to harsh radiation breaks down biological remains, and turns them to dust. It's likely that all obvious traces of organic life have been destroyed. So how can Perseverance identify the remains of long-dead life amongst the dust and stones on the surface of Mars? The solution lies in detecting the ancient chemical traces that living things leave behind in the rock.
You're looking for a chemical signature that life was once there, that life somehow processed the material around it. And the word that we use for this is biosignature, that the chemistry was changed in a way that we can say it must have been life that did this.
NASA scientists pioneer a technique to identify the biosignatures that ancient living things leave behind in their environment. X-ray fluorescence zaps rock samples with radiation to unlock evidence of the organic fingerprint hidden inside stone. The technology is an ingenious way to find life on Mars. Fitting an entire X-ray fluorescence laboratory into the chassis of Perseverance is a big challenge. So NASA scientists develop a special scaled-down version for the rover to use on Mars. It's called Pixel, the planetary instrument for X-ray lithography. On the end of the rover's 6.5-foot-long robotic arm, the instrument focuses an X-ray beam onto a tiny spot of Martian rock. The rock releases a radiation signature that reveals its chemical composition. By mapping the chemistry of the Martian rocks to sub-millimeter accuracy, Pixel can identify the chemical fingerprints that living things leave behind.
The search for ancient life on another planet is not really a smoking gun type of situation. We don't expect to find one piece of evidence that's so striking, make one observation that's so incredible that we just all agree and pack up and go home and say, yeah, there's life on other planets. You have to collect many different observations, many different pieces of evidence, and they all need to point in one direction. We built the payload to give us the best chance we absolutely can of answering that question.
Pixel promises to unlock the hiding places of long-dead Martian life. But is it possible that living things thrive today on the Red Planet? If so, how do they survive? And where could we find them? Perseverance is NASA's first rover to search for evidence of ancient life on Mars. It carries a special X-ray instrument that scans rocks for the chemical signatures that long-dead life leaves behind. But is it possible that the rover could find living things on the Red Planet today?
The surface of Mars today is extremely inhospitable. It's hard for us to imagine any life as we know it surviving for any real amount of time on the surface of Mars.
As far as we know, all life on Earth needs water to survive. So if we want to look for life on Mars, it makes sense to go with what you know, and we want to look for the water there. The problem is Mars is incredibly dry. If we want to look for life, we're going to have to find the water.
The planet's polar ice caps are the only obvious signs of water on Mars today. They contain the same volume of frozen water as the Greenland ice sheet on Earth. Photographs taken by Mars Reconnaissance Orbiter reveal the traces of ancient rivers, lakes, and possibly oceans etched into the surface of the Red Planet. But the liquid water that once filled these features is long gone. Why did it disappear?
Billions of years ago, Mars was warm and wet, very Earth-like. In fact, it looked more like Earth does today than Earth did back then. But today, Mars is dry and cold, and the paths of these two planets moved in two very different directions.
If Mars was habitable in the past and is in the current condition it is today, then something big and something bad must have happened to it.
Planetary scientists believe that something was Mars losing its protection against the sun. The churning molten core inside the young Mars generates a powerful magnetic field. This magnetic field deflects away the sun's harmful radiation. It protects the fragile atmosphere of Mars and preserves its liquid water. Around 4 billion years ago, the core cools and solidifies. The magnetic field turns off, and Mars loses its protection. Radiation from the sun strips away the Martian atmosphere. The atmospheric pressure plummets. The planet's water evaporates into space. The planet turns into the red desert we see today.
At the surface, Mars has the air pressure of about 1% of the Earth's atmosphere, and that's almost like being in a vacuum chamber. What that means is that if you poured out a bottle of liquid water on Mars, it would immediately boil away and become vapor.
The low atmospheric pressure on Mars means it's very unlikely for water to exist as a liquid on its surface. But that doesn't mean it's impossible.
In 2008, NASA's Phoenix lander makes a discovery that reveals how it is possible for liquid water to exist on Mars. Phoenix beams back to Earth images of strange beads of liquid attached to the legs of the lander. What stops this water from fizzing away in the low atmospheric pressure on Mars? Phoenix discovers a clue in a soil sample. It contains perchlorate, a type of salt.
What do you do when your sidewalk is frozen? Well, you throw salt on it. When you mix salt and water, it lowers the freezing point of water so that it can exist as a liquid, even though technically it's below the freezing point of water. So it's possible that if water is salty enough on Mars, that it could be in a liquid state there.
Martian water, if it exists, will be a lot saltier than the oceans on Earth. But that doesn't mean that it cannot sustain life. These are the hot springs at Yellowstone National Park. The temperature of the water in these pools is close to boiling. The pools are as acidic as lemon juice. But microbial life thrives here despite the hostile conditions.
There are locations on Earth that we found life, but we didn't expect to find life. And these are extreme locations where we call the life forms that live there extremophiles.
Some scientists believe that if life exists on Mars today, it will likely share characteristics with extremophiles that live in Yellowstone. Perseverance will collect and store samples taken from the surface of Mars. Future missions will return them to Earth. Scientists will test the samples for evidence of Martian life. But where are the hidden bodies of salty liquid water in which living things could exist now? And how can Perseverance find them? Some scientists believe that liquid water on Mars today could harbor life on the red planet. Where could NASA's Perseverance rover find this liquid hidden beneath the surface? In 2011, NASA's Mars Reconnaissance Orbiter makes a discovery that could unlock the mystery. These images show dark streaks on the slopes of Martian craters facing the sun. The streaks grow in spring, widen in late summer, and then fade away in fall. Scientists struggle to explain these mysterious features. Is it possible these streaks are evidence of large reservoirs of liquid water locked away inside the Martian crust? And if they are, what mysterious process drives them to the surface? A clue lies here in Death Valley, California. This is the driest spot in the USA. Almost as dry as Mars.
If you want to look for life on Mars, it helps to look for places on Earth that are very much like Mars. And one place like that is Death Valley in California. It's very, very dry there. And so you can go there and look around and get a feel for what it would be like to be on Mars.
But even with virtually no rainfall, life still thrives in this inhospitable environment.
Death Valley is one of the hottest and driest places on the Earth. And yet, as you drive around, there are still places where you see little clumps of vegetation. There are even some oases that have water on the surface.
Some scientists believe that the unique geology of Death Valley not only unlocks the mystery of how this arid desert supports life, but also offers a clue to how on Mars, liquid water could seep from below the ground up onto the surface. Death Valley sits on a branch of the infamous San Andreas Fault, called the Garlock Fault. As the rocks here crunch past each other at up to 3 feet every century, they fracture, creating fissures deep beneath the valley floor. Groundwater can collect in the voids, building up pressure that can force water through cracks to the surface. That's how water hidden deep underground can turn even the hottest place on Earth into a green oasis. NASA's InSight spacecraft discovers that Mars likely has fewer and less active tectonic plates than Earth. Scientists think that these plates don't grind together as frequently, so the crust of Mars is less fractured than that on Earth. But there is another way to create a subterranean pipeline that will allow water to escape to the surface of Mars.
Over its multi-billion-year life, Mars has been pelted continually by asteroids and meteorite impacts. So as these asteroids impacted the surface of Mars, they crushed and fractured the crust of the planet beneath it. And these could create channels or conduits for salty water to travel up to the surface.
The water is trapped inside the structure of the rock itself in tiny little bits. But now what can happen is if a crack finds its way down into that rock, all of that rock is underground, under a lot of pressure, so the water is pressurized too. That means it can burst up all the way to the surface.
Today, Mars is a frozen desert. But the rocks beneath its surface are so salty that they could melt the ice and form pockets of liquid water. Some scientists believe that in summer, high pressure forces water up through cracks in the rock. The water seeps across the Martian soil, causing dark streaks visible from space. In winter, the cracks freeze shut and the streaks disappear. The Perseverance rover carries technology that can reveal hidden sources of Martian water. On board Perseverance is a special type of ground-penetrating radar called RIMFAX. Underneath the rover, an antenna probes the ground with radar waves. They can detect ice, water, or salty brine 30 feet beneath the Martian surface. Where there's water, there could be life.
It is possible that deep in the subsurface of Mars, where liquid water is stable for long periods of time, there could be life today, and there could be habitats that are refuges of these ancient habitable environments that were once in the surface, where microbial organisms survived and thrived, and then as the planet globally dried out, these organisms retreated along with the water into the subsurface, and it's possible, it's exciting to think about, that they could survive today.
Advanced radar on board Perseverance promises to unlock the secrets of the geology of Mars. The rover could even find evidence of living things in the Martian soil. But is it possible for life from Earth to survive long-term on the Red Planet? And how will Perseverance lay the groundwork for humanity's next step in space exploration? NASA's Perseverance rover is searching for evidence of ancient life on Mars. The mission is also a crucial stepping stone on the path to human exploration of the Red Planet. NASA plans to send astronauts to Mars in the 2030s. Private companies have ambitions to visit even sooner. The long-term goal is to make the dream of living on Mars a reality.
As you watch this program, starships are being built in South Texas at this very moment for going to Mars, for taking humans to Mars. It's getting real, really real.
But establishing a Martian base is a huge engineering challenge. Up to 250 million miles separates Earth from the Red Planet. A spacecraft carrying humans to Mars doesn't have enough room on board to carry fuel for a return journey.
The thing about rockets is that most of the rocket is fuel, and the people and the payload, the instruments, that's at the very tippy top. You can't bring enough fuel to go to Mars to also come back. So if you go the way things stand right now, it's a one-way trip.
How can astronauts make fuel on Mars for their journey back to Earth? Perseverance carries technology that could unlock the answer. The atmosphere of Mars is 100 times thinner than the atmosphere of Earth. What gas does exist here is almost all carbon dioxide. It is possible to break down carbon dioxide to manufacture oxygen from the Martian atmosphere. And oxygen is essential for burning rocket fuel. NASA engineers fit inside the Perseverance rover, an instrument that promises to unlock the oxygen reserves on Mars. It's called MOXIE. It zaps carbon dioxide with electricity to extract the oxygen from the Martian atmosphere.
What MOXIE will do is live inside the rover and act as a small chemical plant, pumping in carbon dioxide and split that into carbon monoxide and oxygen. In our case, we'll just get rid of the oxygen. We're just trying to demonstrate that chemical process in the dusty surface environment of Mars.
MOXIE activates soon after the Perseverance rover touches down on Mars. NASA scientists plan to run the experiment at different times during the 2-year mission. The results from MOXIE could spawn future technologies that turn thin Martian air into the critical component of rocket fuel.
Imagine you land a much larger version of MOXIE, and it sits there on the surface of Mars and pumps away, pulling in CO2, generating oxygen, filling up a big tank of oxygen. Now, this oxygen can obviously be used by the astronauts to breathe, but of course it could be very important as an oxidizer for their rocket to oxidize the fuel to get them back off the surface and home safely.
Oxygen generators will form the heart of any colony on Mars. A community of 1,000 people will need about 40 generators, each the size of a shipping container. The generators will produce around 2 pounds of oxygen an hour from the carbon dioxide in the Martian atmosphere. Huge storage tanks will hold liquid oxygen to supply the base with air to breathe. And for refueling rockets for the return flights to Earth. This future could be just around the corner, thanks to the pioneering technologies aboard the Perseverance rover.
I think it's possible, very possible, that humans could be on their way to Mars in my lifetime, and I'm extremely excited about that. And I just so badly want to hear those stories of what that trip is like and what it looked like and what it felt like to stand on another planet.
Perseverance rover is part of NASA's most ambitious mission to Mars. It carries a suite of instruments designed to sniff out the traces of ancient life that died out billions of years ago, as well as detect where life on Mars might exist today.
Finding life anywhere outside the Earth, I think, would change how we all view ourselves in a very basic way. In the past, we've been this impossible thing, this rare thing. And if we find life on Mars, it means we truly are not alone.
Perseverance will also lay the groundwork for the next stage of the human exploration of space, testing the technologies that will make a permanent settlement on Mars possible.
Once upon a time, humans were confined to one continent and they spread out. They discovered new lands and new worlds here on planet Earth. This is another new land and a new opportunity. And who knows where that could end up? We've seen the vision of science fiction, but now it's becoming science reality.